Here, we're going to learn how to solve problems like these, where we're given the empirical formula and the molar mass of a compound, and we have to figure out that compound's molecular formula. We're asked to determine the molecular formula of a compound with the empirical formula, CF2, and a molar mass of 200.04 grams per mole. Let's begin by making a chart. Okay, so here's a formula, the empirical formula that we're starting with, and I want to find its molar mass. So to do that, I'll look up carbon and fluorine on the periodic table. I do 1 times the molar mass of carbon plus 2 times the molar mass of fluorine, and I get 50.01. Okay, now CF2, this here is an empirical formula, which means that the number of atoms here, the ratio of atoms here, is as simplified or reduced as possible. Now there are a number of different molecular formulas that all have CF2 as their empirical formula. Okay, so for example, C2F4 is a molecular formula that has this as its empirical formula. Okay, if we took both of these numbers and divided them by 2, we'd end up with CF2. And going the other way, we can kind of say that we got this formula by taking the empirical formula and multiplying it by 2. In other words, this formula is kind of a multiple of the empirical formula. We multiply it by 2 and we get this. Now it's the same for the molar mass. Okay, we take the empirical formula, kind of multiply it by 2 and get this. To find the molar mass of C2F4, we can just take the molar mass of the empirical formula, multiply it by 2, and get the molar mass of C2F4, 100.02, twice what this is. Here's another formula that has CF2 as its empirical formula. C3F6 we get by multiplying the empirical formula by 3. And the same thing for the molar mass. We can figure out the molar mass of this compound by taking the molar mass of the empirical formula, multiplying it by 3, and getting 150.03. We could also take the empirical formula, multiply it by 4. You're probably getting the point here. We get C4F8 as a molecular formula, and its molar mass, 50.01 times 4, is 200.04. This is the molar mass that we're looking for, so it means that this C4F8 is the molecular formula that we want. So what we're really asking is, what do we have to multiply the empirical formula by to get a molecular formula that has the molar mass that we need? That's the background thinking that we want to do with a problem like this. I think this chart really lays things out really clearly in terms of what's going on with the multiples here. But I bet you don't want to have to make a chart like this every single time you solve one of these problems. Okay, so now that we understand the background of this, I want to show you a simpler way that we can go through solving problems like these. Now, as we said before, problems like this are really all about finding what number we want to multiply the empirical formula by to find the molecular formula that has the right molar mass. Okay, we want to find this number to multiply the empirical formula by. Here's one way we can get it. Okay, we can use this equation here, where we take the molar mass of the molecular formula. So in this case, it's going to be 200.04. We get that from right up there. And then we divide it by the molar mass of the empirical formula, CF2. In case you forgot what the molar mass of that is, it's right here, 50.01. Okay. We divide this by this, and we get 4. Here's what this 4 means. It means that we take the molar mass of the empirical formula, and we have to multiply it by 4 to get the molar mass of the compound that we're solving for. We do the same thing to get the molecular formula of the compound. We start with the empirical formula, CF2, and we multiply it by 4 to get C4. It's a 4 because with the C here, if there isn't a number after it, it means that there's just one of them. So we're just essentially doing 1 times 4 is 4. And then we do F2 times 4 is 8. C4F8 is the molecular formula of the compound that has a molar mass of 200.04 grams per mole and has CF2 as its empirical formula. Let's do a couple more examples using just this method without having to do the chart for each one. Calculate the molecular formula of a compound with the empirical formula C2H2O and a molecular mass of 126.12 grams per mole. We'll use this formula to figure out what we have to multiply the empirical formula by to get the molecular formula. Okay, so we'll start with the molar mass of the molecular formula, which is given to us in the problem, 126.12, divided by the molar mass of the empirical formula. So here's how we'll do it. We add 2 times the molar mass of carbon plus 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen and get 42.04. We do this division here and we get 3. 3 is what we have to multiply the molar mass of the empirical formula by to get the molar mass of the compound. Now to get the molecular formula of the compound, we'll take the empirical formula, C2H2O, and multiply it by 3. So we'll get C, 2 times 3, 6, H, 2 times 3, 6, and O, we assume there's a 1 here, 1 times 3, O3. And this is a molecular formula that has a molar mass of 126.12 and has this as its empirical formula. A compound has empirical formula C2H5N and molar mass 86.16 grams per mole. What is its molecular formula? Okay, we'll take the molar mass of the molecular formula, 86.16, and we'll divide it by the molar mass of the empirical formula, C2H5N. Here I have the calculations. 43.08 is the molar mass of the empirical formula. We divide this by this, and we get 2. So 2 is what we have to multiply the empirical formula's molar mass by to get the compound's molar mass. To get the molecular formula of the compound, we'll take the empirical formula, C2H5N, multiply it by 2, and get C4H10N2. And that is the molecular formula of the compound we're solving for. One more example. Calculate the molecular formula for a compound with the empirical formula C2H5 and molar mass 264.18 grams per mole. To find the number that we need to multiply this empirical formula by, we'll take the molar mass of the compound, 264.18, divide that by the molar mass of the empirical formula, which I've calculated here to be 44.03. This division gives us 6. This is what we have to multiply the empirical formula by. Molar mass of the empirical formula times 6 gives us the molar mass of the compound. So we take the empirical formula, C2H5, multiply it by 6 to get the molecular formula of the compound, C12H6F6. And that is how we figure out the molecular formula of a compound when we're given the empirical formula and the molar mass.